Okay, so we're going to keep going on. So we talked about your innate immune system, and now we're going to talk about the adaptive one. Now, this is where we're going to get a little bit more specific. Your innate one was more of a general response. Now we're going to talk about how your body primes for when it recognizes, so it has this like defense system in case that pathogen comes back. So we talked about the first and second lines. Now, this is the third line of defense. This is a very specific defense, and it takes longer to react. So we're going to have those initial white blood cells, neutrophils, macrophages, and all that stuff will go there, and they will try to fight as long as they can. But that third line of defense is there if it's, sometimes we need to say, okay, we have like, that's a specific thing. We've encountered that before. We need to be able to prepare in order to adapt to that. So that's where your adaptive immune system comes in. As I mentioned, it does take longer to react. Now, we're going to use it if the pathogen gets past your non-specific defenses, and it's kind of out of their control. They can't control the infection. So when that happens, they start to send out signals, and that's going to trigger this third line. Now, this is going to be composed of millions of lymphocytes, which happen to be your white blood cells, and they're going to be carried in your blood and both through your lymphatic system. So we talked about how these cells are moved around through the body. Now, what's important is they're going to recognize specific antigens, or remember those are those markers on pathogens, and they're going to respond to vaccinations also. So vaccinations kind of like giving like a cheat sheet to the immune system of how to prepare, because we know that pathogen is probably out there and you're going to experience it. Now, once we recognize these antigens, or those harmful markers, and detect them, we're going to go through and we're going to hunt down those cells that have that marker. So we have cells, and all their job is to do is to look for that marker and get rid of that cell. Now, once we go through and we've gone through this the first time, your body becomes immune to it, and then this is where we get immunity. So we start to make these cells, these memory cells that are primed, and they know what that looks like, so the next time it shows up, we can actually target it a lot faster. So there's going to be two types of adaptive responses. There's going to be the cell-mediated one, and this is going to be done by your T cells. And then there's the humoral immune response, which is going to be by your B cells, as I mentioned. T cells and B cells. How they go through and target is a little bit different. You're going to see with the B cells, they're going to have a little help from the T cells to be activated, and they're going to be producing antibodies, which are going to go and target antigens. And then the T cells are going to recognize specific markers and actually go and target direct cells. So there's different ways that they go through, but they actually work together quite well to get everything done. So just remind yourself what an antigen, it's a foreign non-self molecule, and it reacts with the cells of the immune system. So how do we kind of detect? Well, one thing we're going to look is we look for these antigen presenting cells. We call them APCs. So this is an immune cell. What they do is they go through and they detect, and what they do is they kind of take up this pathogen. And when that pathogen is taken up, it's going to go through and recognize that MHC, that billboard marker. And what it does is it puts that MHC class 1 or MH class 2 molecule out on the outside. And it's kind of like a marker. And it's kind of like saying, hey, this is what we're looking for. This is what the bad guy is using. That's his billboard. You need to find him, and you need to, this is what you're going to be targeted. So it's kind of like, okay, this is what it is, and that's going to tell your T cells, and then they're going to go through and either activate their type of T cells or then let know the B cells. So it's kind of a process that has to happen. That's why this process is a little bit slower than your innate system. So you've heard the term lymphocytes before. So these are going to be formed from your red bone marrow and your shoulder and your pelvic bones. Now where it matures, it'll determine if it's going to be a B cell or T cell. Now B cells remain in the bone marrow where they mature, and T cells migrate to the thymus. Now they're immature, but they have to then be primed and pretty much be, I guess, like an education almost, so they know what type of antigen that they're going to specifically target. We don't have them just targeting anything. We have to make sure that they bind to a specific molecular antigen. It's kind of like a test. So we know that you're going to be specific for chickenpox. You're going to be specific for type B flu influenza or something like that. Now we need to make sure that they only bind to the negative type cells. You want to make sure they don't bind too strongly to your own body cells. You only make sure that, you know, they're working just right, but you don't work them too well, because we don't want them to like overcompensate and actually start killing healthy cells. You will start to develop some of these type of cells during fetal development, and you're going to develop them all throughout your life, because you are going to be encountering all kinds of pathogens on a daily basis, and you don't realize how much you actually have. You have this library of cells that are just primed to target different antigens that you've encountered. So what they do is they use these unique receptor proteins to attach to specific antigens. And there's thousands of different ones out there. Like we encounter so many different things, and you have this library that you just generate. Now, once we attack and we get that specific key model, it's kind of like that lock and key I used to talk about enzymes. And then when I talked about how viruses look for a receptor. We had to get this antigen into antigen binding site just right. So that's when we know these B cells and these T cells are able to recognize specific things. You want to make sure that they only go for what they're supposed to, not for just any type of cell. We want to make sure they target their specific pathogens. So let's talk about B cells a little bit more. Your B lymphocytes, as I mentioned, they are going to mature in the bone marrow. Now, this final maturation steps happen, and they first are going to be called naive mature B cells. That means they're not activated. They're just general hanging out there, just waiting to be called up to line of defense. Now, what B cells are going to do is they're going to produce these little things called antibodies. They kind of look like those little Y-shaped things right there. These are proteins that are going to bind to specific antigens, and then what we do is the B cells are going to turn into like a plasma cell and release a lot of these antibodies into the blood and the lymph. And then these antibodies are going to go bind to cells with the specific antigens, and the antibodies will kind of mark them for destruction and kind of prevent them from further dividing. So they're kind of like, hey, you know, like a blinking red light saying, hey, bad, we need to destroy this, this is not good. Now, each B lymphocyte can only produce specific antibody for one particular antigen. So once it's been primed to a certain type of B cell for that specific antigen, that's all it's going to be specific for. It can only produce those type of antibodies. Now, you do have an initial population that you inherit from your mother's placenta and breast milk, and there's a lot of times where you might actually use some of them. If you don't ever encounter that pathogen, then those B cells will never really be activated, but they're always there. Now, once you encounter a new pathogen, you do keep that around in case you encounter it again. So, like I said, you have this library of B cells just waiting for that next time you might encounter it. So, as that naive B cell sitting there waiting to be called up and get its specific antigen that it's going to then make antibodies for, it needs to learn out what its receptor is going to have to be. Now, so this is where we're going to bring in our T cells, and they're going to be important for notifying the B cell what they're going to be. So an antigen is brought into the cell by endocytosis. We talked about in a few slides, and then that's where we're going to get that MHC class II molecule. Remember, I call that the billboard. Now, what's going to happen is that's going to be recognized right here. So here's the invader. Call that your MHC class II molecule. We know that's bad. And this guy's like, okay, I see that. That's something new to me. He's now sensitized. Now he's just hanging out because the only thing he's going to look for is this little guy right there. That's all you know. So he's primed. He's just sitting there waiting to be encountered. Now he's just sitting there, and once he confirms that it is the right thing, he's going to have to be activated. Most of the time, he's just in here naive, just waiting. And then once a T cell actually recognizes, like, hey, this is something we actually have right now, we need you to actually go through and do your job, he needs to get the T cell to recognize it. So because this T cell's walking around, he's got the signal. He said, "Oh, that's bad." The T cell does confirm it, and then what he does is he said it's going to give him some cytokines, which are those chemicals that cells use to communicate each other, and that's going to activate that B lymphocyte. When that happens, it goes through several rounds of cell division, and some of them will become plasma cells, and they're going to secrete those antibodies. A few of them will stay behind and become memory cells and just sit around and wait till they're activated when the next time that pathogen is encountered. So as I mentioned, some of them are going to be memory cells, and then they just remain inactive. They know specifically that's the type of antigen. Anytime that MHC2 class molecule comes up, I'm going to be called up. Once I'm activated by a T cell, they just hang out. They just stay and hang out. Some of them will divide into plasma cells, and what they do is produce large amounts of antibodies. Now, these antibodies then are released into the blood, and what they can do is they can now bind to viruses and bacteria. They can inhibit cell clumping. They can actually stimulate inflammation, block the receptors. They can do a lot of things. So here you see them surrounding and neutralizing a virus. They can actually signal cells from macrophages. It's like, hey, we need to engulf that. It can activate the complement activation. So now proteins will look for that specific antibody and come and destroy the pathogen too. So this was part of the active immunity system, or there's also passive. So you have antibodies that you produce on your own from these B cells. These are a response to an antigen. This is your response. So antibodies have different ways they can act on cells. Now, if you produce it, it's your active immunity, but there's also passive. So this is from an outside source. This is where you have pregnancy of classic placenta, antivenom, and for snake bites. This is where we're given antibodies. In some of the early COVID treatment, they were talking about using antibodies from other donors to try possibly go and target the COVID virus. So that was what I was talking about. That's possibly using passive immunity to kind of fight the symptoms. Now your T cells are going to respond to those APCs on the innate immune system. And what they're going to do is induce immune responses by releasing the cytokines. So they're waiting for those APCs to recognize the bad cells and present them with the markers. And once they do that, they recognize it. What they're going to do is they're going to stimulate the B cells to start the humoral response. So remember that humoral response, some of them become memory B cells, other ones are differentiating the plasma cells and secrete the antibodies. Now, it's going to help detect those APC signals also and directly kill the infected cells. So it's not only important for activating the B cells, it also kind of activates itself, and it's going to kind of go through and actually kill cells in its own way too. Now there's two main types of T cells. We're going to have our helper ones and then our cytotoxic ones. So remember that these guys, they mature in the bone marrow and they migrate to the thymus where they mature. And they're going to help develop, or they're going to develop their T cell receptors. And you'll hear the term CD4 and CD8 receptors. It's just talking about more what's specific, and it kind of goes what CD4, CD8 is talking about if it's cytotoxic or helper cell. I say they make the immune system so much more complicated than it's supposed to be. So once they go through selection process, they're naive T cells, and they kind of circulate the system looking in lymphoid organs. Now, they're going to need some help to recognize pathogens. So they're kind of naive, so we need to make sure they know what they're looking for. This is where those APCs will play a major role. What they're going to do is they're going to say, hey, like this dendritic cell right here. Look, here's this molecule waving a flag. This is what you need to look for, okay? You are going to be looking for this one. This is what you're going to be looking for. They know exactly what they're going to be targeting. And depending if they are a cytotoxic cell or a helper cell, that's going to determine what they're going to do next. So these guys pretend they were naive at first, and then they're just circulating the blood system, lymphatic system also, and then eventually this dendritic cell is like, hey, I found something new and you don't have a job yet. So this is what you need to look for. This is what you need to look for. These cytotoxic cells are going to look for this specifically and go kill those cells. helper cells are going to go and activate the B cells and have them be alerted. So the helper cells, they indirectly tell other immune cells about potential pathogens. So he's just sitting out, and then the APC cell comes and says, hey, look, I found this right here. And he's like, okay, boom, 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 I must alert everyone. So what he's going to do, he's going to tell interferons, secrete those chemokines, and he's just going to be like a big old tattletale and like tell everyone, Chicken Little, sky's falling, sky's falling. And he's going to go through and secrete those cytokines and getting more of the white blood cells to the area to fight the infection. He's going to stimulate those naive B cells to secrete those antibodies. If he notices that, he'll actually go to the B cells that are his memory B cells and tell them, okay, boom, activate, go. Now, if he's a killer cell, that CD8 one, what they're going to do is now is they know what they're looking for, and they're going to go and kill it. Their job is to go attack and destroy infected cells. So they're just ID it, they know what they're looking for, and they're just going to try to kill those cells before the pathogen can replicate and escape. So they will identify that, and some of them will stick around too. Some will actually go and destroy the cells, but then a small subset will actually stay and become those memory T cells. So anytime they see that, they can be activated a lot faster. Now, the cytotoxic cells, they're constantly, once they've been primed and like those memory cells that are hanging out, they're still going to constantly be patrolling because now they're always going to be looking for this class marker right here. So when it comes to organ and tissue rejection, what you're happening is you're getting tissue that's different from your cells in your body. And as I mentioned, cells have these little markers on them. Well, these C cells, the cytotoxic ones, they're looking for those foreign markers. And once they see that, they know it's like, oh, that's not good. I need to go and kill it. So that's why we need to, when we do organ and tissue rejection, they're kind of trying to control the cytotoxic T cells. So they want to give you those immunosuppressive drugs, to inhibit the T cell response. So you start to get a memory when it comes to this, which is important. As you mentioned, you have memory B and T cells that stick around. So your primary response is the first time you encounter any antigen. You're going to have a clonal selection and proliferation. You made all those B cells. Some of them turned into plasma cells. Some stuck around and made memory B cells. Same thing with the T cells. Some went to go be cytotoxic. Some went to go be the helpers. Some became memory cells. Same thing happens. Now we're going to keep some of these memory ones because we never know if we might see that invader come again. Now once we have those memory cells, if they recognize the invader, our response is a lot faster because we don't have to prime those naive cells. It's like, hey, teach them. It's like, you're looking for this, now go find it. They know exactly what they're looking for, and they can go target a lot faster. So we have these cells, and they can not stay activated and may circulate your system for many years. So I think that's quite cool how your body does that. And vaccinations fall in this category. What they're doing is they are giving you kind of like a cheat sheet for how to prepare. So you have like, it's like saying, hey, this is what it's going to look like, or it's like, these are the answers to the test. So what we're doing is we're telling the innate system how to prepare for it and actually make these memory B and T cells before we actually have to fight the infection. So I mentioned the lymphatic system a little bit before. This is just a system of tubes running alongside your blood vessels. Now you're going to have some excess tissue fluid, and it's going to kind of go between your bloods and your vein and all other stuff. Plasma can actually leave, and other fluids leave the blood at the capillaries or diffuse from the tissues. Now within this, you're going to have lymph, which is just your fluid, and it's going to have a lot of your white blood cells, but not your red blood cells. Also helps in transportation of nutrients and waste, but it's really important when it comes to your immune response. There are several lymphatic organisms, as I talk about in the bone marrow. So this is where we're going to produce those blood cells. So remember I talked about the lymphocytes, the B cells and the T cells. They're produced here, but then they leave, and depending where they mature determines what type of cell they're going to be. We talked about the thymus, where the T cells like to mature, and this is going to be super important because remember, those are make up the cells that are going to activate the B cells, or they're going to become those cytotoxic T cells, or eventually become some memory cells. You do have lymph nodes throughout. These are structures in your lymphatic vessels that are going to filter lymph as it flows through, and they help slowing it to make the macrophages work. Most of the time, you notice when you're sick, these are going to become really inflamed, especially think about in your throat and all the other stuff. That's one area you could check. And then your spleen plays a key role here. It's going to filter blood with more macrophages, so it's going to remove a lot of the waste. You need to make sure you kind of get rid of the waste that we have. This is a good review video kind of talking about all the different stuff that you saw on these last couple of slides. So one thing is we got to make sure that we don't attack ourselves, all right? So we have a system, we tell it to work, but we want to make sure that it doesn't go rogue on us. So that's where we talk about immune tolerance. So this is the acquired ability to prevent unnecessary or harmful immune response to detected foreign substance known to not cause disease. Sometimes some pathogens will come in and they might be good and beneficial, but we want to make sure that we don't kill them off too early. You'll see that there's going to be some of these called these T regulatory cells, and they're going to be in your liver and your lymph nodes, small intestine, some other areas, and their job is just to be specialized and suppress local inflammation. They want to make sure that it's like, okay, I know you're doing it, but you're doing maybe too good of a job. So I know that was a lot. Here's some more review videos on that. I said don't freak out too much. Remember, you did get to use your notes on your test on all your chapters. So don't worry. The immune system is quite complicated, but hopefully you appreciate it a little more after this one.